part of my graph here. Nearpod should be pulling up. It should hopefully, so VHPKO, let me know if the code is not working. It should work, so we should be fine. I just want to make sure. Okay, it should look like this, correct?
Yeah, I think it will, unless you don't turn
Yes. Ooh, I don't know what that was. It shouldn't be this. And it works. You have to answer some questions on paper then. Okay, you're gonna have to look up first. Because you won't know what the problem is.
It's $1,000.
Alright.
Because they don't make it. It was released in 2014.
Okay.
I don't know, it's a bunch of options go. I don't know, like $20.
Alright, I'll let you get set up here. I know a lot of you are still trying to get final problems put together. Okay, are we good to go? I know those others are going to be coming in here and saying, alright, here's what we're going to talk about today. Kind of outline. I'll kind of go through this as you guys are clicking through your Nearpod itself. We are going to continue with those postulates and kind of review. We have one new one today, which is a theorem. And so I thought it would be kind of nice that we get to at least see this and you get to go through both. Alright. I don't know if it's turned for you. Did it actually turn?
Yeah.
Perfect. All right. So what you're looking at there, that is a postulate 2.5 in front of you, correct? We talked about postulates yesterday. We finished with 2.4. The goal today was to talk about postulates again, but to go from 2.5 to 2.7, and it says 2.4 here, 2.5 to 2.7, and to talk about today, for the first time, a theorem. And go through the definition of what a theorem is. That's kind of our goal today. Now, we're going to do proofs. We are going to go back to algebra proofs. I did warn you of that yesterday. You guys did a nice job yesterday with the couple examples that we had in class yesterday. Like, we had to come up on the board, present. We're going to do the same thing today. We're going to move around the room and get a little more interactive with that. Okay? You will eventually need paper today. I'll leave the Nearpod code on the board. The reason why is if you get kicked out, sometimes it logs you out. You can get back in there, especially when you're trying to visit other websites and whatnot. Okay, postulate, real quick. It's a mathematical statement we accept as truth. We don't prove it. In fact, they're almost impossible to prove. We talked about that yesterday. We accept them as truth. It's valid. But they're the basis of mathematics, right? We talked about, that basic operations, add, subtract, multiply, divide. Those are based on axioms, right? Axioms has the same definition. All right, this should be what's on your Nearpod, correct? Okay, notice what it says. 2 points line a plane, then the line that contains those points also lies in that plane. The big idea here is you started with the plane, you started with the dots. Then you can draw the line itself that's on the plane, okay? Like this, okay? But you have to start with the plane and start with the dots on it. So on this first drawing we're going to do, because I'm going to have you draw again and submit answers again, I will already have the plane drawn for you. You're welcome. And all you have to do is put points and draw a line, okay? And you have to label it and give me answers, okay? So, are we ready to go here? Is everyone kind of getting logged in? All right, so the first question here. First question. So read the directions. Read the directions on there. If you don't see the directions on your Nearpod, there's a little blue tab in the upper left corner. You'll need to do a little drop down, click that little blue tab. It will bring down your directions. Okay, so you need to draw 2 points on your plane. Start with that, label them. Then draw the line that contains those 2 points. Label that. Then you have to name the plane, name the line, and state the postulate we just talked about. So hopefully you're paying attention. But again, you have to go in that order. You have to draw the points, then you have to draw the line, label that, label the plane, name the line. So there's lots of stuff. And You're welcome, I gave you the plane was already drawn for you, so you didn't have to draw all those crazy different planes. Yesterday, the later classes were pretty funny. Like, I had a lot of like potato-looking planes. They're just circles. They just didn't even want to draw, you know, an object that looks like even like rectangular. Because it doesn't have to be rectangular. Like, planes don't stop. There's no border. I just thought it was easier if I had it drawn for you automatically. Okay, once you have all those labels, remember your question is to name the plane, name the line, name the postulate we just talked about, what number it was. Hopefully you're paying attention to that. Now, when you're done, before you hit submit, I don't know if you've already submitted, maybe you want to double check with your neighbors real quick. Did you have everything labeled? They can point out things. Did you label something wrong? Try to submit this as quick as we can because we're going to go through a couple different things today. And I want to be done with this PowerPoint in the next 10 minutes so we can go on to our next activity. So I'm going to click quick today. You will not have a lot of time to go through other things. So we're going to go about 10 minutes here. Okay, I got quite a few, just waiting on a select few others. Okay, I'm waiting on about 5, 6 of you here. So let's submit. Waiting on 2 others to hit submit. Let's try to stay on the Nearpod website, don't be shouting around for t-shirts. Perfect, all right. So, some of the ones I liked. This is good. I just want to talk about this one. It's colorful, it's pretty, you can see it in front of you, it's nice. Okay, I like the fact they used different colors, you didn't have to, it's just pretty. They named the plane, they used the cursive letter. They named the line, they used the cursive letter. They had the postulate. The only thing I would have changed here, on the 2.5, I would have put postulate in front of it. Like, actually write the word postulate. The reason being is that we are going to get into theorems today. They have the same numbering system. So if you just saying 2.5, eventually, I don't know if you're talking about the theorem or the postulate number. You do have to know those. Postulates, by the way, are free game for the vocab on the test. Yeah, you have to know them by number. So, that's part of the vocab. So, that might be a reason why you want to be a little more specific. Okay, but that was a good one. Now I'm not sharing yours, it's going back to the original picture. Here's another one. This is acceptable to me. I like this. Okay. They put a P out front, so they're actually signifying that it's postulate 2.5. That shorthand for doing it. They have the line labeled with the AB. Now you did not have to put line out front. That's why I brought this one up. AB has the little arrows above it. Don't put line out front. You're double saying what you just told me is line AB. That's literally what you just typed. Okay, I wrote. Okay, plain K is fine. You did that. If you did the 3-letter system, you'd have to put more points on that plane, and that would be using one of the other postulates we did yesterday. Does anyone happen to know the postulate yesterday that allowed me to draw multiple points on the plane? 2.4 allows me to put extra points, so you could have labeled it with 3 points. Okay, that's really good. But that was the only difference here. I like to show you those just to make sure that you're comfortable with that. All right, let's move on. Okay, 2.6. So 2.6. 2 lines intersect, then their intersection is at exactly 1 point. 1 point. Now this is the picture you have drawn, right? So 2 lines are intersecting, their intersection is exactly 1 point. Now how do you name that point? How do you write it?
Point P.
Point P. You actually have to write the word point and then put P. Don't just write P, point P. Okay, now this one, what I'm going to ask you to do on this one, instead of drawing, because I know you guys are getting used to the drawing idea, I'm going to have you answer a short question about it. Okay? So, I want you to think about a real-life object. A real-life object, it's kind of an open-ended question, that would represent an intersection like that. A real-life object in this world. So, if you can't think of it, Go Google it right now. Try to find a picture on your Chromebook. Yes, I'm allowing you to go open up a different tab. Go find a real picture of something that would represent, you know, an intersection, or that would give you one point where things cross. That type of thing. Because I want you to see the importance of it. Like, why are intersections important? Find me a single picture. That's all I need to see. Now the Nearpod is allowing you to kind of venture out to a different website. Usually it would kick you out of the Nearpod, so just kind of heads up, we were doing in the future. So you're trying to find a real life example that would represent an intersection like that. Like what would be something that you'd actually see it used for? I'll give you one example once you guys have yours. Okay, if you have your picture, try to make it full screen, and I'm going to walk around with it. Because it's important that you see this, because you can't, I think on the Nearpod you can type things, but it'd be nice to see like an actual physical picture of it, if you have one. If you don't, maybe you just want to say it out loud, you can type it in there, that's fine. I'll show you a couple different ways that I thought of it. There's an obvious one, and there's some not so obvious. Okay, anyone have a good example they want to show? Okay? Alright, what do you got there? What do we got? Okay. Alright, so, Wheel, you want to explain what you have here?
Basically I thought maybe road intersections would work,
Yeah.
or four or more roads connect into one area.
Yeah. That's what I'm seeing a lot of people have. Yeah, they have a road intersection where, you know, sidewalks cross roads, that type of thing. She has one where it's actually highlighting in color. This is what you'd see on like a driver's test. You'd see something like this where it actually highlights which road you're turning into. Yeah, that's a great example. Like, I know a lot of you have really good pictures of that. That's good. Now, what I thought of, and I know this is just thinking outside the box a little bit. I was thinking of like when you're putting Kia furniture together, or you're putting like cabinetry together, or you're doing some type of fabrication, you're building something, right? You're building an object. You have to line up the walls correctly on those IKEA furniture. Then you can put like screws into the actual objects themselves to hold them together. There's an intersection of objects, and that's where your screw would go, right? It has to go right through the hole so that it actually fits the furniture together snug and fit, right? That's what I thought of. You're looking at where lines cross, because you're putting the two things together. They appear as lines when you look at them from head on. A lot of people don't see it that way. They think of roads and other things. They're obvious, that's good stuff, but I'm thinking like just fabrication, building something. Can you line those things up correctly? Because it's coming down to one single screw that you have to put in there. The screw kind of represents your point. That's what I was thinking of. But these are good examples, don't get me wrong. It is important to know the road systems. I mean, they have a driving test for a reason. All right, next, 2.7. So 2.7, two planes intersect. Two planes intersect. Then they intersect at a line. Two planes intersect, they form a line. Now, in this room, is there an example of an intersection of lines?
The walls.
Okay, walls, okay, you can have the corner. Any other examples? Is that the one you were going to say? Ceiling and wall, yeah, ceiling and wall, you can see the definite line. I thought of a marker board, like where two marker boards meet. These are two planes. They are making a line right down the middle. That's what I was thinking of. Or where two doors meet, like two planes. Like if you're looking at my back cabinet back there, the two cabinets meet, it makes a line. Like there's two doors, two planes actually crossing each other. That's what I was thinking of. Okay, those are just kind of obvious things, okay? All right, now, let's get to our first thing. We have the theorem. It should appear on your Nearpod. Okay, a theorem. Now, we had this in the last chapter. This was on our last chapter test, the definition of what a theorem is, but we've never actually seen one, right? A theorem is a mathematical statement or conjecture that has to be proven. Like, we don't accept it as truth until it's proven that, yes, this actually works. The proof could be super simple, right? It could be just listing off the property or definition that makes that thing work. It could be one step, like, oh, hey, this is because of definition of this object. Or it could be showing some simple algebra. That's why we've been practicing algebra proofs. To prove that, yes, these walls are the same number. That type of thing. Okay? Conjectures. It's your concluding statement but you're using inductive reasoning. Proofs are a lot of inductive. It's calling back knowledge, don't get me wrong, there's some deductive skills where you have to call back to things, but that's what makes proofs so difficult for people, is that you have to think about the problem all on your own. There isn't just one set proof that works for every single math problem. That's what makes it so difficult. I can give you tons of examples in class, but until you try one, you don't fully understand every aspect of it. You don't understand the logic that goes into it. Proofs develop your brain in such a way that you can do really quick problem solving, because you can justify reasoning, and it opens up you to a whole new branch of mathematics. Okay? The method of proving these statements. There's a couple different methods. We've actually talked about them in class. There's the informal proof, which is paragraph, you explain it in words. Sometimes it's nice to do that. Think about the problem before you start, walk yourself through the steps. 2, do statement reasons. That's what we did on all of our algebra problems yesterday. I call it statement reason. But I think on a couple of weeks ago we just called them algebraic proofs, where you just use algebra, but it's statement reasons. We talked about indirect proofs. That's one of the hardest forms. You start with this assumption that they're wrong, and you try to prove why they're wrong. And eventually you can't. And that would make it true then, if you can't prove that it's wrong. Now that's a dangerous way of doing a problem, because that requires an incredible amount of logic. That you're assuming they're wrong, and you have to show why they're wrong. Because if you're assuming things wrong, if somehow you come up with some weird thing that you did wrong, and you actually prove that they're wrong with incorrect mathematics, that's dangerous. Because now you have this assumption that they're always wrong. That's one of the hardest. I try to usually steer clear of this one. It's usually easier going the direct way, statement reason. Okay, here's your theorem. This is your only theorem that you have. Okay, let me go back to your Nearpod, so hopefully this will appear for you. I don't know, is it even appearing?
No.
Nope, that's Postulates.
Oh, what happened? Oh, it's not even working. Alright, whatever, we'll exit. Okay, here it is. You're going to need to write this down. This is our last slide anyway. It was fun. I'm sad. The one slide I had on there that you needed today and it's not working. Alright, whatever. That's how Nearpod goes sometimes. Okay, M is the midpoint of AB, then AM is congruent to MB. So M is the midpoint of AB, then AM is congruent to MB. So if this is the middle, the midpoint, the middle dot, then what we're trying to prove is that this stick is congruent to this stick. Okay. The proof of this, because it is a theorem, right? This is theorem 2.1. The proof is using the definition of what midpoint means, but it's going logically through it. So, proof of theorem 2.1. We have to start with what we're given. Line number 1. So, when you do a proof, a geometric proof, this is your first time experiencing this now, you have to state, what did they give me in the first line before the word then? What do they provide me?
M is the midpoint of A.
Boom. M is the midpoint of AB. You were actually write that down. M is the midpoint of AB. The reason, that is literally given to you. Now, notice, the reason off the side, given. If you get the first line wrong, I don't know how to help you anymore, because it's literally printed. It's given. Now, going further, the second line of a geometry proof is defining, if they used a bunch of vocab words, what did that vocab word mean? That's what the second line is reserved for. So, if you go in your book and you look up the definition of midpoint, what midpoint says is that M is the middle point between two endpoints. It means that the distance from A to M is equal to the distance from M to B. Now, when I write it like this, notice I put an equal sign, correct? I put an equal sign. Equal sign means the numbers. Notice I left the bars off the top. I'm literally talking about the distance from M to B. and the distance from A to M. So these are the distances. So whatever those numbers are, they're actually equal. And the reason why this works, that is literally the definition of midpoint in your book. That the distances are equal. Well, if the distances are equal, then that's the definition of congruent. So step 3, this is your dot, dot, dot line. If the distances are equal, then the segments are the same. That this segment, AM, and notice I put the bar above that, talking about the actual picture, the segment should be congruent to M to B, because the reason, that's the definition of congruent. That definition of the little equal sign with a little tilde above it, the little squiggle above it, literally means that they're equal in size, shape, and measure. They're the same shape, they're exactly the same size and measure, because that's what line 2 said. Midpoint means their measurements, their distances are literally the same number. Do you see the difference between this line and this line? Do you see like the notational difference? This is talking about the raw number, like 5 inches, 5 inches. This is talking about the actual pictures are equal now because of those 5s are the same. That's a proof. You just saw your first geometry proof of the year. They're easy. You know the first line's got to be given. It's whatever they tell you. Second line is usually reserved for defining what one of those words meant. And then either third, fourth, fifth, whatever it takes, usually it's up to 5. That's going through the logical argument of like trying to get, usually if like they give you a definition, you can usually jump to kind of what you're going to. This one was easy because we're just trying to prove that things are congruent. That just means that they're equal in the size, shape, and measure. They will get way more difficult. Like that one's easy. Now, you just gotta get used to that. That's something you haven't seen before. We've been doing algebra proofs in this class. Now, I do want to practice some algebra proofs. So, here's what we're gonna do. You need a piece of paper out right now. Now, in your little pods you're sitting, in your little pods, I will have you move around today. So you're not going to be staying there. So you might want to pull up all your stuff. Just get your notes out in front of you. Because people are going to be sitting at your station here in a second. We'll have to get up and move. I'll probably have you join some stuff. So Alex, let's have you go over here with these gentlemen. You guys, I'll probably have you come up here so you're in like the main 6 pods. I know you're kind of back there. I'm going to put a problem in front of you. And I want to see on your notebook paper, can your group figure out how to do this algebra problem? Does that make sense? So you're going to have to get up and physically move after you're doing this. So I'm going to hand these out. So these are problems that we did yesterday. So they shouldn't be anything crazy new. Do not write on this piece of paper, please. Okay, gentlemen, I'll have you guys come up here. You ready?
Hey, George. Yeah.
Okay. All right. Take the picture. I'll take this out.
No.
On everyone's piece of paper that you have, every group, it should only take you 3 lines of work. Everybody's paper should only take you 3. What I would like you to try to figure out today is what properties also go with those 3 steps. Now yesterday we were really focused on the math, and I kind of filled in the properties later. Today is really hammering down what are the property names. Okay, it's the same types of problems we did yesterday, so don't feel like these are brand new. It should be very, very similar to what we have. We're only going to rotate like once or twice. We're not going to go through the whole room because if you did that, you'd just be doing the same problems over and over and over. Okay, when your group thinks they have it, I would like to see it. Okay, so I'll just kind of walk around the room and let's double check what we have. Okay, so first one, distributed, yes, dissociative. Okay, so your properties are correct. So the math, we did it out at number 3. Then you switch to the parentheses. The only difference here, I put the y outside of that one. And then you'd multiply and you
That was
get what's the reason?
Oh. Yeah, actually.
Okay,
Oops.
I'm gonna have you guys, we'll probably have you guys rotate from also about, does that make sense? So just wait for it now. Okay?
I don't know what it is, but I wrote down 10.
I don't know.
Okay, these are the same property names, so that would be your line number 2, and this is your first property. Yeah, just put like a little bracket, so just add a property on top of it. First line, and then everything else is correct, so you did your math. You have the 7, I mean, 2, so that's good. All right, okay, good. I'm gonna have you guys rotate probably one spot. Okay, anyone else want me to double check? Okay. Okay, can you do agree? Moving things around. Negative 3, yeah, because that negative sign is attached to the 3. Okay, keep going, yeah. Okay, so first one is the hand of the 2, then you switch to parentheses, which you guys jump to the next step. The associative, I would have just put inside this 2 and 3, and over here I would put the 2 and 6, like in the parentheses together. Yeah, that one. And then you could get to these, this one, right? Because you could bypass this one, because you did the math and all that stuff. No, you have to have the first, second step, you have to have that step where the numbers are written first, inside parentheses next to each other. Then you can get to your last. Okay, so, right, so I'm gonna have you guys rotate one spot. Here in a minute. Yeah, you guys will go one. Okay? Okay, you guys ready to go? Muted, distributed, distribution, no associates, distribution. And then sub, you got three.
And I have a mixture of those in
Yeah, so the only property that we can switch associative is distribution or, sorry, back, reverse distribution.
Just like how I didn't include the diluted
Back.
color.
Okay, I'll have you guys rotate, have you guys go over there. Okay, so just jump to that spot. You guys can rotate, okay, you guys ready to go?
Good job.
Okay, your properties are correct, I'm gonna have you rotate to that box over there, alright? You guys can rotate, you guys can rotate.
That's not okay.
Yep.
You should know that.
This is your last spot today. Last spot today.
No, 4th of July. That's just a...
And that's,
I know more about the October and November.
that's not